this time, I will discuss fermentation technology. Fermentation is metabolic process that produce chemical chain in organic substrate through the action of enzyme. Fermentation technology is the use of organism to produce food, pharmaceutical, and alcoholic beverage on a large-scale industrial basis. The basic principle involved in the industrial fermentation technology is that organisms are grown under a suitable condition. The major product of fermentation technology produced economically on large-scale industrial basis are wine, beer, vinegar, ethanol, cheese, hormone, antibiotic, protein, enzyme, and other useful product. Fermentation is one of the oldest technology used for food preservation, and it is a process digesting certain substances that lead to a chemical conversion of organic substance into simpler compound. The table shows some historical development of fermentation technology. Let's see this one. Since ancient time, humans have explored the fermentation process. 7,000-year-old jar containing the remains of wine now on display at the University of Pennsylvania were excavated in the Zagros mountain in Iran. Curd is another very popular fermentation product described in the berikut. It still remains a popular food, and the technology of curding milk is also found in a number of texts associated with Yajurveda. A sweet substance known as soma juice, prepared by the Vedic Aryan, is supposed to be the first product of fermentation in India. Rigveda shows that fermentation technology took its first step in connection with the preparation of soma juice in India. Finally, the term fermentation is derived from the Latin word fermentum that stands for boiling. The French chemist Louis Pasteur found gemology, a study of fermentation, when in 1856 he connected yeast to fermentation process. Fermenter is the large vessel containing considerable quantity of nutrient media by maintaining favorable condition. Commonly, fermenter provide facilities for the process of fermentation, such as contamination-free environment, a specific temperature maintenance, maintenance of agitation, aeration, and pH monitoring levels of oxygen, etc. There are several basic functions of a fermenter. It should provide a controlled environment for optimum biomass product yield. It should permit aseptic fermentation for a number of days, reliable and dependable, and meet the requirement of containment regulation. Containment involves prevention of escape of viable cell from a fermenter or downstream processing equipment into the environment. It should provide adequate mixing and aeration for optimum growth and production without damaging the microorganism or a cell. The above 2 points, item 2 and 3, are perhaps the most important of all. The power consumption should be minimum. It should provide easy and dependable temperature control. Facility for sampling should be provided. It should have a system for monitoring and regulating pH of the fermentation broth. Evaporation loss should be as low as possible. It should require a minimum of labor maintenance, cleaning, operating, and harvesting operation. It should be suitable for a range of fermentation processes, but this range may often be restricted by the containment regulation. It should have smooth internal surface and joints should be welded wherever possible. The pilot scale and production stage fermenter should have similar geometry to facilitate a scale-up. It should be contrast using the cheapest material that afford satisfactory result. There should be adequate surface provision for industrial plant. Now let's see component of fermenter. This one, top plate, clamp, and others. This one, inoculation needle, a pit pump, syringe pump, sample pipe, inlet, there are several types of fermenter. The first one is external recycle airlift fermenter. This one for producing bacterial biomass with methanol as substrate. Internal recycle airlift fermenter. This one for producing yeast with oil as substrate. Tubular tower fermenter used for making beer, wine, vinegar, etc. Nathan fermenter. This fermenter used in brewing industry. And stir fermenter. This one is used for making antibiotic. Several fermentation process such as bath fermentation, pit bath fermentation, and continuous fermentation. So let's see this figure in the right side, operation mode of bioreactor. This is bath process, pit bath process, and continuous process. So you can see the difference between the three, one by one. Now let's see bath fermentation. Bath fermentation is what is desired, what is described as a closed system whereby the substrate and producing microorganisms are added to the system at the time zero and are not removed until the fermentation is complete. In bath fermentation, there are 6 phases of the microbial growth such as lag phase immediately after inoculation there is no increase in the number of the microbial cell for some time, and this period is called lag phase. This is in order that the organism adjusts to the new environment they are inoculated into. Then accelerated phase, the period when the cell just start increasing the number is known as acceleration phase. Then log phase, this is the time when the cell number steadily increase. Deceleration phase, the duration when the steady growth decline. A stationary phase, the period where there is no change in the microbial cell number is the stationary phase. This phase is attained due to depletion of carbon source or accumulation of the end product. And the last is that phase, the period in which the cell number decreases steadily is the die phase. This due to die of the cell because of cessation of metabolic activity and depletion of energy resource. Depending upon the product required, the different phase of the cell growth are maintained. For microbial mass, the log phase is prepared. For production of secondary metabolite, for example, antibiotic, the stationary phase is prepared. Now let's move to feedback fermentation. Feedback fermentation defined as an operation technique, as an operational technique in biotechnological process where more nutrient or substrate are feed supplied to the bioreactor during cultivation, and with the product remain in the bioreactor until the end of the run. It is also a type of semi-batch culture. In some cases, all the nutrients are fed into the bioreactor. The advantage of the feed-batch culture is that one can control concentration of feed substrate in the culture liquid at arbitrary desired level. In a continuous fermentation, fresh medium is continuously added to the fermenter, while used medium and cell are harvested at the same time. In principle, continuous fermentation processes could be more economically compared with the batch or feed-batch one. However, continuous fermentation does have weakness such as lower concentration of final product, more complicated downstream processing, difficult process flow sheet design, and long-term process sterility maintenance. All of these complexity can be attributed. That can be attributed to the difficult to main to main sterility during the long time frame of the continuous fermentation process. Solid state fermentation is one of the technique of is one of technique in fermentation. Solid state fermentation method defined as the growth of the microorganism in solid material in the absence of pre-water. Commonly, this solid state fermentation used for production of antibiotic, enzyme, alkaloid, organic acid, biopharmaceutical product. This process consists of depositing a solid skeletal substrate such as rice or wheat grain on a flat bed after seeding it with microorganisms. The substrate is then left in the temperature control room for several days. Solid state fermentation is recognized to commonly offer a series of advantages over submerged or liquid fermentation, such as higher yield and productivity, extended stability of product, lower production cost, lower protein breakdown, in this case, which is especially important if the enzyme is the target product, lower contamination risk, lower energy requirement, lower energy cost for sterilization, lower fermentor volume, and lower or absent catabolic repression, and so on. This method is used for production of antibiotic, enzyme, alkaloid, organic acid, biopharmaceutical product. Submerged fermentation is a method of manufacturing biomolecule in which enzyme and other reactive compounds are submerged in a liquid. The process is used for a variety of purposes, mostly in industrial manufacturing. Submerged fermentation involves the growth of the microorganism as a suspension in a liquid medium in which various nutrients are either dissolved or suspended as particulate solid in many commercial media. There are several principles in submerged fermentation. The first one, submerged fermentation is a process involving the development of microorganisms in a liquid broth. Second, this liquid broth contains nutrients and it results in the production of industrial enzyme, antibiotic, or other product. Third, the process involves taking a specific microorganism, such as fungi, and placing it in a small closed flask containing the rich nutrient broth. Fourth, a high volume of oxygen is also required for the process. The production of enzyme then occurs when the microorganism interact with the nutrient on the broth, resulting in them being broken down. And the fifth, the bioactive compounds are secreted into the fermentation broth. Several difference between solid state fermentation and submerged fermentation. Let's see this one. Utilization solid substrate like bran, bagasse, and paper pulp. In this case, utilize following liquid substrate such as molasses and broth. Substrates are utilized very slowly and need to be replaced. In this case, substrates are utilized quite rapidly and need to be replaced constantly. Best suited for fungi that require less moisture content. In this solid state fermentation, best suited for bacteria that require high moisture content. And others, for example, inoculum ration is always larger, but in solid state fermentation, inoculum ration is usually small. A system may or may not involve agitation, but in the solid state fermentation, agitation is often essential. Then now let's see several major products of fermentation technology. Industrial chemical, ethanol, lactic acid, organisms that use in this industrial chemical. For example, Saccharomyces cerevisiae, Lactobacillus bulgarius, enzyme for production of alpha amylase, protease, lipase, and organism involved in this production of enzyme, Bacillus subtilis, Bacillum species, Saccharomyces lipolytica. And then antibiotic, penicillin, streptomycin, chlorampicillin, vitamin, riboflavin, and vitamin B12. The organism involved in this group are Asparagosidae and Pseudomonas dentificians. So I think that's all for this moment. Thank you so much.